lectures by Professor Jinraj and Professor Paulette. And actually, Professor Paulette is like our part of our faculty already. I hope next year she's gonna come back again. All right, and we have fifth year student, and we have graduate student, and some Ajahn lecturers, the dean and vice deans, many of them, and lecturer Ajahn Thantakon, Ajahn Ying Sawat. So we're gonna start with welcome speech by the dean.
On behalf of Faculty of Architecture, KhonKaen University, we would like to welcome for a cool welcome to our faculty, to our school of architecture. For both Professor Jinraj Joshipura, that I spell right, and Professor Paulette Hebert, and both of professor will give us an interesting presentation today, and we would like to thank Professor Chamnan Bunya Putipong for cooperation. At last, I think our relationship and collaboration will be continued to the next time. Okay, thank you very much.
Next, we have to finish the formal thing right away. So we would like the dean to be on the maybe on the stage or not, and we keep the small souvenir from the dean, from our faculty. First, Professor Jinraj. The clear is made by our staff and student. And second, Professor Paulette. You make a photo, good photo. And then good photo. Firstly, I think the lecturer อย่างอาจารย์จินรัตน์นี่เขาจะเลคเชอร์เรื่องของพลังงานทดแทนอะไรก่อนแล้วเขาจะแนะนำการเรียนต่อที่ MIT เรารู้จัก MIT กันไหม MIT คือมหาลัยอันดับต้นๆของโลกเลยก็ลองดูแล้วของ Professor Paulette นี่จะให้แนะนำมหาลัยอย่างเดียวเลยโอกาโฮมาสเตทซึ่งอยู่ตอนกลางของประเทศก็ถ้าใครสนใจจะเรียนต่อ1ภาษาอังกฤษเตรียมแล้วก็คุยกับอาจารย์เลย เพราะว่าจริงๆแล้วเราปี 5เราไม่ใช่ปุ๊บปั๊บจะได้ไปเราต้องเตรียมภาษาอังกฤษเตรียมอะไรได้ด้วยเพราะฉะนั้นหาข้อมูลพวกนี้ไว้ก่อนแล้วก็จริงๆแล้วถ้าไปจริงๆมันจะมีทุนมี scholarship พวกนี้เยอะพอสมควรก็ต้องถามอาจารย์ได้ก็ I just tell the student that for if some of them want to study more for master degree can consult Ajahn Paulette Professor Jinraj about that. And so firstly we would like to begin with Professor Jinraj for the lecture. And Professor Jinraj is the visiting lecturer at Puerto Rico USA, and he graduated from MIT. He's gonna present the renewable energy and sustainable architecture.
So good morning, everybody. Thanks for coming. I will first point out a mistake of mine. The first word should be alternate and not alternative, but I apologize for that. Now, how many of you know Christopher Columbus? Or how many of you don't know who is a Christopher Columbus? Everybody knows. That's good. So, but do you know whether he was married or not? Nobody knows that, right? Even Paulette doesn't know that. Okay, so we'll find it out. Okay, so what I'm going to cover here are different prevalent buzzwords that we find in the renewable energy world and in sustainability. So people talk about alternate, new, renewable. We talk about renewable as solar and wind. And we talk about sustainability, and many architects are proud to claim that they can cut off from the grid. And if you ask them a detailed question further than that, they are not cut off from the grid. They have actually created their own power plant as a backup. So there are a lot of misconceptions that I'm going to address, and I'm going to question, and we will question together on these concepts. And we will also examine the concepts and rationale behind these words. So if you look at the space science, there is a semantics mistake which comes from the social sciences and literature. So for example, when the astronaut went to the moon, the ground control asked them, so how is everything up there? Is that a correct question? No, it's not a correct question, because it is how is everything out there? Because it's in the orbit. Because when you say up and down, you are assuming that the earth is flat. So this was pointed out by a famous American thinker, Buckminster Fuller. And the same mistake, I believe, that we are carrying in the renewable energy world, and I want to point it out, those mistakes. So for example, let's take an example of a Christopher Columbus. He came to North America. He was actually looking for India, but he lost the way. And he came first to Hispaniola in the Caribbean. That's why Puerto Rico is a Spanish-speaking country, Cuba is a Spanish-speaking country, and the Dominican Republic is a Spanish-speaking country. He did not go to Massachusetts. Even if he go there, there is no evidence of it other than a piece of stone. Okay, but see, he came from Spain to this Caribbean island here, as the arrow points out. Now, how did he come there? So let's examine the relationship between Columbus, his wife, and the renewable energy. So he started from Spain, and his wife must have asked him, so where are you going? He says he's going to India. She must have asked him, how long will it take? How long will it take to go there? He didn't know. How many days will you stay there? He did not know. When will you come back? He did not know. So his wife kept on asking him nagging question. Okay. So forces he relied on to navigate were wind and solar. None of them were unpredictable, unreliable, and uncontrollable. Because he did not know whether he goes out in the ocean, there will be wind. Will he navigate? There will be cloud, there will be storm, there will be rain. He did not know anything because he relied on those energy sources which we call renewable. That means we can control it and we can renew it. It was not truth. He could not have answered those questions. So, and he knew that he could not answer it. So it means that he would not have been able to answer the question of his wife, and the fact that he undertook that journey shows that he must not have been married, otherwise he would have given up that journey. So let's say there are other people who have tried to do this even today's time. And in 2008, a mariner took a round-the-world journey on a solar boat. Now, can you imagine how many disciplines he had to know and understand before he can undertake journey? So I calculated myself from my own guesswork and my knowledge of nautical science, 42. So renewable energy world and energy and power generation is so multidisciplinary. There is no way one discipline or like architecture can answer all the questions. Now, is renewable energy new? My proposition is no, it is not new, because I teach 4 hours of history of renewable energy. And that is also 1200 years of history of renewable energy. So it is obvious that if something has a history, it cannot be new. And if something is new, it cannot have a history. So renewable energy is not new. So why are we talking about it? If you look at the historical energy perspective on energy, is this energy was derived in primitive times from variety of sources. And all the renewable energy sources were abundant in supply. And our first sources of energy came from wind and solar, which were available. It was our first conventional energy source. Then why did we shift? We shifted because energy crises were frequent, because there were not enough rains, there was not enough food, we could not rely, and people migrated from one place to another. They could not carry their energy supplies. So we needed something which is very reliable. And our demand for electricity and energy increased and supply became less. Therefore, we shifted to something which is reliable, available, controllable, which is biomass and the oil and the coal. Because you could quantify them, you could arrange their supply, and you could generate energy. So what we call fossil fuel as conventional is actually opposite. It is the solar and wind which were conventional, and fossil fuels were new. So the hydro dam was also new, but hydro as a supply was abundant in the previous times. But we concluded that solar and wind and biomass and hydro are renewable in a false manner, because they are not renewable. So for the first attempt occurred in France in 1949. They created a sort of solar furnace, which is way back, almost nearly 50, 60 years ago. It was conducted in France. And Paulette, you may see the name Audio. I don't know whether it's a correct, I'm speaking a correct pronunciation. Now, what is the best energy source? So I have created a 19 criteria here, which qualifies as something a best energy source. You try to put solar, wind, biomass, hydro, whatever renewable sources you want to put, compare against coal. So I asked my students to make a spreadsheet. On the left side, you see all the criteria. On the right side, on top, you will see different energy sources. And instead of first, we started with an exercise in qualitative form. That's where we created our doubt. And then I said, well, to score it, it should be numbered. If it is 100% meets the criteria, it is 1. If it is a bit ambiguous, you put 0. And I guess what was the result? Result was that nuclear energy was the best source that satisfied all the criteria. Now, that result should not be acceptable in a normal way, but if you do the analysis, that is the best source. So if you are complaining about nuclear, then you please understand that everything in this world is nuclear. Our nuclear cell has a nucleus. Solar energy is nuclear because solar energy is generated by a nuclear fusion. And it is that fusion that sustains itself, and therefore we get a radiation in terms of a light. Okay? It is not a renewable at all. It has nothing to do with Earth, what's going on in this Earth. So only 15% of the energy that comes on the on our Earth, rest is absorbed, 85% is lost during the transmission. And out of that, we have achieved roughly 30 to 40% of 15% as something which is available on solar panel. So you can imagine about 30% of 15% is how much it is for 100%. So it is not that much as you think. And it cannot be sustained because you cannot remove the cloud, you cannot stop the rain, and you cannot control it. And therefore, it is not renewable at all. So let's look at this scenario. Can solar energy be disturbed by any scenario? Yes, it is quite possible. What if a meteorite hit Earth and it knocks off Earth from the orbit of the solar? Can you drag the Earth back? No. If there is a pollution, can you reduce it? Yes, we can reduce it. What if the solar system as a solar as a planet disintegrate? And this is not a joke. If you look the astrophysics article, you will find lots of this predictability written by the astrophysics people in the scientists, astrophysics scientists. So you cannot restart it, you cannot control it. It is not renewable under any circumstance. Let's look at hydro and biomass. Are they renewable? Well, you have seen famine in the places where there was abundant rain. Even the aquifers under the ground keep on shifting. And a Japanese scientist published several papers that where there was desert, there was jungle, and where there was jungle, there is a desert. So they were not predictable and they were not renewable. So yes, you can make, and I will come back to the natural and man-made disaster like tsunami and hurricane, what is its impact? I have some photographs. So I don't believe even hydro and biomass are renewable because we deforest, because you architect need projects and you need to deforest to build the building. Otherwise you cannot design building, you will die of hunger. So you will continue to deforest. And as the population grows, that will continue to happen. So in the sense, total amount of biomass keeps on reducing on Earth for both natural reason as well as man-made expansion. And that is not renewable. You are not going to reverse it unless you kill everybody and destroy all the building and plant a tree again. But we call them renewable again. This is a photograph from my two apartments in Puerto Rico. You'll see a lot of waves there. That means there is a lot of wind is there. That's why there are waves. And therefore we have a Bacardi rum factory where we have wind turbines. And I look at this picture from my window and I am sure that they are getting the wind turbines are working and they're getting energy. Sometimes in summer, it is so beautiful. But it is beautiful because there is no wind. That's why I could see the bottom of the ocean. There are no waves. That means the Bacardi rum factory, which relies on the wind turbines, is not getting any wind, and they're not making any money, and they're not producing electricity. Can they change it, the situation? Can they restart the wind? No. So how is wind renewable then? It's not renewable. It's simply available. But we still call it renewable. So let's go to fossil fuels. Are they renewable? My answer is yes, they are renewable. but we don't call them renewable. So how the fossil fuels are formed? They are renewed over time through fossilization of all kinds of organic matter. People, animals, vegetation, everything, they go into fossilization process and they keep on renewing themselves. They turn into biomass, coal, or oil. So we do not call them renewable because the rate of depletion, that is what we use, is faster than the rate of renewability. It takes 1 million years to renew the biomass, the fossil fuel resources. But that doesn't make them not renewable. In fact, they are renewable because can you stop them? No. Can you increase the rate of renewability? Yes, you can. If all the Hindus and others bury their dead without a coffin so that the microbes can enter it without any obstruction and start decomposing the material, you can increase the renewability rate of the fossil fuel. So to me, they are renewable. So fossil fuels are again renewable, controllable, reliable, and available because you can locate them where it is, you can transport them, you can store them so that you can generate a qualitative, predictable power supply system. So we were using renewables before, which were what you call conventional renewable sources. To me, were conventional, and we started the humanity by using them. Then we shifted to the fossil fuel because we realized that those were bad. Now we have come back to say, no, these fossil fuels are bad, those ones are better. And now we think that they are new. They are not new. They were there before. It is these fossil fuels were new. So let's go back to the issue of a couple of other buzzwords and how we achieve it. For example, in architecture, we talk about net zero building. And I wonder myself, why net zero? Net zero assumes that there'll be no future energy demand, that there'll be no more energy consuming gadgets, that you will live with the demand that you have and you will not aspire for anything new. You don't want a net zero building, you want a net positive building, sorry. Why? Because architects love the concept of net zero is because they can say, I designed a net zero building. The I is very important in architecture. In a net positive building, you are not talking about I, because there is no knowledge in architecture that you study by which you can make a building produce more energy than you need. That requires engineering. That's why I call it is engineering the architecture and not architecting the engineering. So we have to put our ego aside and let those who know energy technologies better and those who can invent it to work on this area. This is my personal opinion. Now, let's take some example of limitation. This is a beautiful island off Puerto Rico. This is where Pirates of the Caribbean 3 was shot, on this island. Can you sustain a life there? There is no way you can sustain a life there. It's beautiful, but it's only for photogenic. It's to go there, snorkel, and come back. Issues related to sustainability at building level is the demands are 24 hours a day. And reducing energy demand is a nice idea, but there is a limit how much you can reduce. Because as you ask for more gadgets and more things, you want a better quality of life, it will demand more energy. So important thing should be not just keep on reducing the demand, but rather how can we generate it? Because the world has not run out of energy. It's a passive approach like Gandhi. And the Indian monks and Buddhist monks who eat what they get. The real idea is to produce in abundance that you can enjoy it to the fullest. So I myself do not agree to many of the ideas of passiveness that came from ancient Indian religion and Gandhi. There I agree with the Western world, where they create abundance and prosperity. And for that, they use ingenuity, technology. So there I agree with them on that. Besides, solar is only available 6 hours a day. Wind is intermittent, and there is no predictability in quantity or quality. Now storage, why store it? What do you think a lake is? A lake is a storage of energy. What do you think these trees are? The trees are storing the energy of solar energy. So they are storage. So when you create a building level scenario for energy, you tend to find solution which caters to the need of the building and caters to the need and the ego of the architects. Energy generation, distribution, and the whole power generation technology should be detached from the building. It should be based on a microgrid, and I will show you why later on. So I give you one example here of urban dynamics. Where I'm teaching in Puerto Rico, the university president asked me, can you make the guest house completely energy independent? I'm sure you must have a guest house here in KhonKaen University, where visiting faculty and the visitors come there. Problem was that first photograph shows to the left, where at 12 o'clock there was plenty of sunshine. In the afternoon, it was shaded. By another time, it was completely shaded. But this is also the simulation of, I went to the municipal registry office and asked them, can you give me plans of all the building proposals that have been submitted? Because those buildings will come up in next 5 years. And they will cast shadow on this roof. So if I say today I have made this building net zero because there is no shadow on it, in 5 years' time there'll be shadow and there'll be no energy generated there. So these urban dynamics by which urban growth occurs and the tall skyscrapers start casting a shadow, and this I saw in phenomena in KhonKaen myself. I'm staying at Pullman Hotel. I came there 10 years ago when it was Sofitel. And I took pictures 10 years ago, and today I see KhonKaen has expanded enormously, and there are so many buildings and so many tall buildings are coming up. So if you try to put a solar panel in low roof building, and afterwards another skyscraper comes, and that destroys the whole potential of solar energy, that's not a good thing. Because that means you have made a bad decision on investment. There is no return on that investment. So before you put a solar panel on any building, you have to know what is the future growth. Where is it coming from? Can you assure for next 20 years there will be no shadow on the building? So this is another issue. Let me show you some more example. This is beautiful building somewhere in Bali. It's been built by 2 American couple, and they live there. But look at their demand. Hardly any energy demand. They are not asking for air conditioning. They are not asking for natural light. At night light. They only use candles. And they live in a mosquito net. They have no demand. Can you replicate this throughout the world? If you replicate this and all the buildings are made up of wood like this, there will be no single tree left on the planet. So you cannot replicate everything that we talk about as architects called sustainability and using natural materials. It is not tenable, it is not sustainable. Let's look at this scenario. We have in Puerto Rico wind turbine installed, and this is a big solar farm. After Hurricane Maria and Irma, this is what happened. Wind destroyed 2 technologies, solar panel as well as the wind turbine itself. If we had cut off from the grid and if we had destroyed all the fossil fuel power plant and shut them down, there'll be no energy for 2 years. Because who will build those, who will invest money again to build this solar farm? These are private farms. They will say, well, we can't afford it anymore. Where our power plant using gas, coal, and bunker oil were standing. Within a week, we had a power. That means fossil fuels were more reliable, more robust, more available, more predictable, more controllable. And renewable energy was not. So what we need is an integrated energy system. It's a portfolio of variety of fuel sources, not only solar and wind. And you combined and created integrated energy system. So if one of it fails, the other one will take over the supply scenario. So if you talk about cut off the architectural building from the grid, which is architects love it, if agro industry, petroleum industry, oil refinery, steel plant, they were never connected, sugarcane industry, they were never connected to utility because they had enough energy in their industrial processes so that they can satisfy their requirement. But that was long time ago, 100 years, and they are still like that. I went to Kawasaki steel plant in Japan. There were no human beings, and there was no external connection because they were producing enough heat to make their own waste heat using a steam turbine to produce electricity. They didn't need anything. So that is one suggested approach, which is using the industrial processes and integrated energy system. So this is what is an ideal system where every source and every power producer is an independent power producer and they supply it to the common grid and not individual buildings. You can supply it to the grid, but you cannot make it net zero building. You use it, produce it, and supply it. Get it when you need it. You are just one of the power plant. So I further studied the sugarcane industry for Jamaica, and then I applied it in Okinawa. Here in this industry, I used entire industrial process of sugarcane industry. And I also took the Kingston, which is capital city of Jamaica, and I used entire urban waste and whatever methane gases were produced. I combined it to create an integrated energy system which doesn't depend on sugarcane, and it depends on multiple sources of fuel. And I called it an integrated agro-energy system, which is, one building is not important there. It is the robustness of the system. So my conclusion is, most of building cannot achieve 100% of energy independence. And my example of it is, recently, before I came here, I was involved in a competition of microgrid to supply electricity to various pharmaceutical industry in Puerto Rico. You will be surprised that the insurance company that insures the roof of the pharmaceutical industry prohibits use of solar panel on top of the roof. So how can you make that pharmaceutical industry net zero? You cannot, because insurance won't allow it, because they don't want any leakage, and pharmaceutical industry has so much infrastructure of chemical pipes, air conditioning, and so many things that you cannot even put the solar panel on it. So this is what is important is microgrid, which is the integrated energy system, versus the net zero building. So now we go to the next part of our buzzword, which is the sustainable advancement, which I call the sustainable advancement. So various definitions of from UNDP in ecology, in architecture, in economics, they say that Earth is finite, so are the resources, because Earth is round. That's what the Malthus, the economist, propagated. And therefore, we have to use the resources judiciously, otherwise we will run out of it, even for us or for the future generation. Now, does science and technology buy this fear-mongering? The answer is no, they are not buying it. That's only from social sciences. So, the concept of Malthus and the concept of sustainability is like saying that drink water from a glass in such a way that water must be retained for all of us and for those who will come in the future. Is that possible? That's a magic. It's not possible. So what are my assumptions? My assumptions that human habitat is the entire ecosystem and not the dwelling. Sustainability is passive, unequitable, and maintains status quo and limits the growth. So I don't buy this concept of sustainability. Digital era offers access to the world beyond human sensory perception. Renewable energy is not reliable. New advancement in materials science makes recycling cost ineffective. This is exactly opposite view of what is prevalent. You think recycling is cost effective? I'm saying no. So my faith is in human ability, and that's why I call this word advancement and not sustainable as a status quo. So let's look at this innovative and passive advancement. Look at this left side picture from Africa. It has used pickup truck of a Toyota pickup truck and put a tire on it and put a cow in front of it as a primary engine. That engine is very efficient because when you park your cart, you release the cow and the cow will find and fuel itself. You don't have to do anything, right? It's very ingenious. And they're using the tire because before the tires were made of wood, now using the rubber, that means they are reducing the friction. And the bull or the cow has no friction except the weight to carry. The cow must be very happy. So the second one is they're using a Coca-Cola bottle and a water heater to get hot water into the wash basin. That's ingenious. Ryan, you could do that in your farm. The third one is the motion detector. That is, the water comes out only when somebody moves his hand there. And that's very nice. I like that idea. This is an example of ingenuity where you're dancing, you're creating energy. This is nice idea, very fashionable, very effective and nice because you are supplying the water to this plant. So then comes the next question. Which came first? Technology of recycling or the idea of recycling and the policy of recycling? Anybody can answer that? Which came first? Come on, Thai students, you need to wake up. Which came first? The idea of recycling or the technology of recycling? Nobody knows, okay. If you think the last sentence, government and architects idea, you are wrong. The reason is, let's take example of material aluminum. 1.4% of Earth's crust is made up of raw material for aluminum. So there is abundance of supply. However, and there are operating aluminum smelters at 235 all over the world, but it takes only 5% of energy to recycle the aluminum, then go to mining in Bolivia, bauxite mines in Bolivia, and get it from there. So tell me, any businessman who wants to produce aluminum extrusion section for your window, what he will do? He will recycle it because that makes economic sense. It is not because government is saying or architects are saying that let's use recycled material so the aluminum smelter produces aluminum for windows and doors from the recycled material. And the second question I will ask you is, often you utilize and say that I as an architect make sustainable building because I use recycled material or recyclable material. If you can go to the market and find me any material that cannot be recycled, I will give you $1,000. There is no material on earth that cannot be recycled. The point is, what do you mean by recycle? If you think when was KhonKaen University built? 100 years ago, 50 years ago, 60 years? 50 years ago. Do you think it will last for another 50 years? Okay. If you, after 100 years, if you take a steel bar from this building that broken down and sell it to the steel industry of that time, you think steel industry will exist? No. You think they will produce the same steel which was produced 100 years ago? No. There are no material in the market right now. Even after recycling, the qualitative, that is material characterization, is different. Lot of research has gone into it. Lot of alloys have been mixed. You are not going to find a recycled material. You will find a reused material where some of the components have been reused, but that is not recycled. That's completely misconception. So, coming back to it, when aluminum goes out of this building for smelter, it doesn't come back with the same aluminum. It is a different aluminum. So the whole world of architects are not getting it. Sorry, to say. And believe me, I'm an architect too. So we are not getting it. So let's say conflict between sustainable building and a recycled building. Metals are recycled between 10 to 25 years. How many of you have a car? Do you use the car which is 15, 20, 30 years old? No, you scrap it. Do you do the same thing with buildings? Do you scrap your building after every 25 years? Can you go to your client and tell him that, I'm going to design a building which will only last for 25 years? He's not going to accept it because he doesn't want his building to be destroyed in 25 years. No bank will finance it because all the financing is 30 years and beyond. So you cannot use material and send it for recycling as if the world is waiting for architects' building material for recycling. World is not waiting for that. So you can design whatever you want to design, and you can use any material you want to use. World out there is not waiting for your buildings. So you have to design buildings which are long lasting because it is the most capital intensive projects, buildings, and technologically backward. So we are not going to, so this idea of using a recycled material doesn't fly with me. So last conclusion is, problem is that if we design building that sustain over time, then we cannot use recyclable material. Otherwise, we are trapping those material that could have been recycled. So don't use recyclable material. Let the industry get it as fast as possible. So so if you designed a long building, otherwise your building will be sort of listed under temporary architecture because it's 25 years is a temporary architecture in a building life. So what is the solution? Solution doesn't lie with architects. They lie with the material scientists, physicists, chemists, and all that. So third alternative is to create new material, and that's what is going on all the time that we don't know. So this is where what I'm involved in, I beg to differ with architects. Now you might ask me, so is it possible now to design a material based on the characteristics? That is, when you say you chose a material in your design, you are saying that I chose this material and it has this many characteristics, I apply it in architecture. What I'm talking about is different. We as an architect decide what material we want, and material scientists will go and manufacture it, invent it, and that is now possible. And is that within the scope of architects? No. But for me, everything is my mission. And why? because my interest goes back in 60s. These two films, one of them shot in Phang Nga Bay in Thailand, both use solar energy. They were made in last century. You were not even born. So again, I re-emphasize that you don't know what renewable energy is very old. This was my studio in 1971. You see here on the left side, there I created a roof with a space frame, which you can see in the cross section on the right. And what I did was, if this is the space frame side, I used the south side to put the solar panel, north side to get the light, and the other two sides were for rainwater collection, east and west. So I was involved in it in 1971. Then I did my thesis called in 1972, which is called Cyber Equilibrium, which says that future architecture will be subset of self-regulating dynamic environmental system, enveloping a cyberspace open to information and energy in order to sustain its essential constant and variable. 1971. Okay, a lot of these concepts are new to architecture now. Am I right? So how I derived that word, it derived from cybernetics, ecology, and equilibrium. At that time, PC was invented in 1981 after my thesis, and and cybertecture does not mean introduction of technology alone. So that is a separate topic of presentation of mine. This was my two photographs showed how my title page of the thesis was. Architecture is open to information and energy. This is from another film of Stanley Kubrick called Space Odyssey 2001. I am very fond of films and I learn a lot of things from the films. So I built a biofuel plant in Nigeria in 1988. My thesis at MIT on renewable energy was 1993, where price of oil was $15, $16, and I didn't get a job based on renewable energy because nobody wanted me. Nobody was even interested in it. I was a guest researcher, so this is my background where I'm coming from. I didn't stay in architecture, I diversified in variety of disciplines. So if I have to graphically describe my career as an architect, this is what it looks like. So the blue area is most of the architects and allied fields are. This is the architect's typical path, when almost 70% of the architects stay in that field. 10 to 13% bifurcate. And 2.5% may be working in the cafeteria there, or he starts a cafeteria business. I just met a student of yours. But mine path is like this. So I've worked in this many disciplines without studying any one of them. I have 2 patents in information technology while I was working at IBM. I've worked everywhere in every discipline. So I don't consider my life as a mission to remain as an architect. And therefore, I will tell you about where the material science, where I am focusing on. So this material, T stands for Tony and J stands for my name. I hold 50% equity in this company, and we have a patent, and we are going to produce a nanomaterial which will be 20 times stronger than steel and with far superior characteristics than any material you have ever seen. So this was a characterization done by Lockheed Martin, NASA, and many companies of the material that we produced. This is a car at Dubai airport made up of carbon fiber material, not nanocarbon. So you can see this material already in use in carbon fiber. This is the prototype that we built and we produced the material. And it was tested by NASA, Lockheed Martin, and Department of Defense in US. and each machine could generate 200 million in gross revenue. So your question will be, where will we get energy for production? Right? That is the first question you will ask me. Will we use renewable or non-renewable or fossil fuel? Where will we get energy? We'll be producing our own hydrogen, so we can run our own hydrogen gas turbine. We don't need anybody's energy. We don't need any fuel. Will you run out of raw material? Yes. If you stop all the air pollution on the planet, we'll run out of the material. So would you deplete natural resources of architect's earth? No. Will you get it from Mars? No. Not from any planet, but from between the planet, from the air. That will be our raw material. So instead of building castles in the air, we will build castles in the air made up of air. That is where the science and material science is going. So our effort with our limited knowledge in architecture is restricting us with our own inhibition and concepts of what we think the sustainable world should be. So, our material will not deplete resources and hence sustainable. So, I'm not trying to discourage you. What I'm trying to tell you is, yes, we need words of wisdom, but we also need words and act of optimism. And by what I'm doing, I'm telling you that there'll be enough material in the world, and you will not run out of it, because science and technology is going far ahead. So these are the other topics for the future that I've already given lectures on this, but not this forum. So, is that okay? Yeah. So don't go. There is 2 more slides. So Chuman, Mr. Chum, am I saying correct name? He asked me that what advice can I give you for studying abroad in Western world, that is in US, Japan, or anywhere you want to go, MIT, Harvard, wherever you want to go. So I'm going to talk about 2 slides very briefly. And I will give you this advice not because I'm a professor at a particular university, but when I was a student at MIT, I was elected representative of the student council, and I sat on the admission committee, so I had 1 vote. And for 2 years, I examined 729 applications coming from the student. And when I looked at those applications, I realized, and I started reflecting on my own application, how it was. Because every person who gets 750 applications has about 2 minutes to spare on each application. So how can you present your application so outstanding that it stands out? So first is a best fit approach. That is, for example, Dr. Powlett is studying on the human ecology and lighting and other material. If you go to her and say, I want to study sociology of straw dog in KhonKaen, it's not the best fit, because that is not what she's expert at. So if you want to study, you have to choose the right thing. What that university offers, what is the faculty background, and does it match what you want to study? Or can you match yourself? Can you study what they are doing? Otherwise, it's not a best fit. The second thing is, will the education that you're going to get and spend your parents' money is going to help you? Can you afford it? I couldn't afford it when I was a young boy with the long hair up to here. I had no money. I went to Africa to earn my money. My parents couldn't afford it. So I found my own money. Then you have to study the department and see what that department offers. You have to understand the degrees. You look at the faculty profile. Can you work in the same area where they have a grant? Then they will be very interested. They will look at your profile and you want to work in their grant, you will be helpful to them. Then you will get a teaching assistantship or student assistantship, and you will get a scholarship. Third thing is preparing your application. You should have a clear statement of purpose and not ambiguous. It should be written very well, to the point, absolutely honestly, and it should, in one page, tell the examiner of the people who decide your application, which includes students and the faculty, that this guy knows exactly what he's talking about. This student, male or female, has a clear understanding of why he wants to study at this university. That is very important. You could have 100 out of 100 grades, but if your interest and what the university offers doesn't match, then your application will be rejected, not because you are bad, but it is not a best fit. And I'm sure Paulette will highlight all these things better than me because she has a day-to-day experience. And the recommendation from your faculty is very important. So respect your faculty, work with them, study them, study their work, try to impress them with your clarity of thinking. They will write a good recommendation letter. That's very important. So, and then all supporting documents. You need a visa, you need a TOEFL score and a GRE score and all that are minor things. But to me, statement of purpose is most important, and the recommendation letter. Thank you very much.
Thank you very much. Firstly, I would like to translate in Thai for students. ก็เมื่อกี้คุยกับอาจารย์บอยพอดีผมจับประเด็นเขาได้บ้างไม่ได้บ้างนะฮะก็คือถ้าเราฟังไม่รู้เรื่องไม่ต้องตกใจนะเพราะว่าอาทิตย์2 อาทิตย์ประมาณ3 เดือนเทอมแรกของการไปเรียนที่อเมริกาผมก็จะรู้สึกเหมือนคุณนี่แหละผมฟังอะไรไม่รู้เรื่องเลย เพราะนั้นไม่ต้องตกใจแต่นี้ก็ยังไม่คือหัวข้อเขามันค่อนข้างที่จะยากนะและทีนี้เขา propose ไอเดียที่แบบเมื่อกี้คุยกับอาจารย์บอยนะอาจารย์บอยช่วยผมด้วยนะ ก็คือว่าเขา propose สิ่งที่มันแตกต่างจากคนอื่นแตกต่างที่เราเรียนอย่างเช่น Renewable Energy คืออะไรนักศึกษาตอบได้ไหม Renewable Energy มีอะไรบ้างยกตัวอย่างเมื่อกี้มีในสไลด์พลังงานอะไรฮะพลังงานอะไรเป็นพลังงานทดแทนบ้างแสงอาทิตย์ลมเขาบอกไม่ใช่แต่เขาบอกว่าอะไรใช่เมื่อกี้ในสไลด์ฟอสซิลคืออะไรคือน้ำมันเขาบอกน้ำมันคือ Renewable Energy เพราะว่าเขาก็มีมุมมองเขาก็มีการหาไอเดียมาอะไรเงี้ยแล้วก็บอกว่าไอ้รีไซเคิลไอ้วัสดุรีไซเคิลเขาก็บอกว่ามันรีไซเคิลไม่ได้จริงมันแค่ reuse มันใช้ได้แค่บางส่วนอะไรเงี้ยผมว่าก็เป็นมุมมองที่ทะเลาะก็สนุกอะทะเลาะกันก็สนุกแต่คนไทยไม่ชอบทะเลาะกันฝรั่งก็จะมีการเสนอไอเดียที่แบบแตกต่างจากคนอื่นอะไรเงี้ยมันก็เมื่อเช้าผมพาไปดูอาคาร Net Zero Energy ที่ผมออกแบบของมหาลัยเนี่ยเขาบรรยายเมื่อกี้ก็ด่าเละเลย ประมาณนั้นก็เลยก็เป็นสิ่งที่น่าสนใจมันเขาไม่เชื่อ Net Zero Energy ไม่เชื่อว่ามีจริงเพราะว่ามันก็คงไม่Net Zeroแต่จริงๆแล้วพวกนี้มันเป็นนโยบายมันเป็นกลยุทธ์เขาเรียกว่ากลยุทธ์หลอกล่อให้คนเนี่ยทำหรือว่าสถาปนิกนี่ออกแบบให้เกิดการคำนึงถึงคอนเซิร์นพวกนี้มากกว่าถ้าไปจับผิดอย่างเงี้ยจับผิดได้หมดแต่ผมชอบการที่แบบถกกันแล้วก็เถียงกันด้วยแต่เขาจับที่ word ก็คือคำว่าความหมายมันอย่างนั้นจริงหรืออันนี้ก็เป็นประเด็นที่สำคัญเพราะนั้นสถาปนิกโดยเฉพาะสถาปนิกไทยนะต้องลองอย่างเงี้ยลองทะเลาะกันลองอะไรบ้างโดยไม่โกรธกัน อันนี้เป็นประเด็นที่ผมได้นะอันนี้เมื่อกี้นี้เขาพูดถึงการไปสมัครเรียนต่อ สิ่งที่สำคัญที่เขาพูดสรุปได้ไหมว่าคืออะไร สิ่งที่สำคัญที่สุดอันสุดท้ายนี่สำคัญมาก recommendation letter จริงๆแล้วเมื่อเช้าที่ผมเพิ่งรุ่นพี่คุณอยู่ตอนนี้ไปเสิร์ฟอาหารอยู่ที่อเมริกาแล้วก็สมัครเข้าเรียนมหาลัยหนึ่งก็อินบ็อกซ์มาหาผมว่าอาจารย์จะมีมหาวิทยาลัยที่อเมริกานี้ส่งอีเมลมาถึงอาจารย์นะเพราะผมให้เบอร์อีเมลผมไปมหาลัยนี้อยากให้อาจารย์คอนเฟิร์ม recommend เขาเพราะเดี๋ยวนี้แต่ก่อนนี้เราจะทำจดหมาย recommendation แล้วก็อาจารย์เซ็นให้แล้วเราก็ไปถือยื่นมหาลัยแต่จริงๆแล้วrecommendation letter เนี่ยมันจะต้องแต่ก่อนนะมันก็จะใส่ซองแล้วก็ซีลบางทีอาจารย์ต้องเซ็นว่าคุณไม่ได้เปิดแก้ recommendation จดหมายรับรองนั้นแต่เดี๋ยวนี้มันก็จะเป็นบางมหาลัยเขาเริ่มกรอกออนไลน์ละปล่อยให้อาจารย์คุณไปกรอกออนไลน์เมื่อกี้เขาสรุปว่าคุณต้องเอาใจจากอาจารย์ดีๆนึกออกไหมว่าอาจารย์นี่แหละจะเป็นคนเขียน recommendation ให้คุณเวลาคุณไปสมัครเรียนต่อหรือขอทุนหรืออะไรเนี่ยพวกคุณส่วนหนึ่งเลยจะต้องกลับมาหาอาจารย์ช่วยเขียนให้หน่อยซึ่งมีประจำเพราะฉะนั้นคุณก็ผมถึงบอกว่าทุกคนน่ะผมจะมีปัญหามากเลยพอกลับมาถึงแล้วบอกว่าอาจารย์บอกอาจารย์ทุกคนก็คงจะรู้พอจดหมายมาบอกอาจารย์เขียนจดหมายแนะนำรับรองให้ผมหน่อยผมจะเรียนสมัครเรียนที่นั่นที่นี่ทีนี้ผมก็ถามว่าเฮ้ยผมจำว่าคุณเก่งไงไม่ได้เลยอะทำไงแสดงว่าเราไม่มีจุดเด่นที่จะนั่นไงถึงบอกว่าฝรั่งในเวลาที่เขาได้อะไรได้ทำอะไรได้ทำกิจกรรมเป็นดารานำฝ่ายชายก็ยังมีอะไรเขียนไว้นึกออกว่าเราต้องหาพอยท์ที่เราเด่นเล่นกีฬาก็ได้ทำไปช่วยไปสร้างบ้านไปทำออกค่ายอาสาอะไรแต่ถ้าเป็นผู้นำได้เป็นประธานได้เนี่ยมันก็จะสตรองก็จะนั้นมากขึ้นเพราะฉะนั้น recommendation letter อีกอันหนึ่งคือ statement of purpose คือเราอยากเรียนอะไรพวกนี้เราต้องเตรียมไว้เราจะบอกอยากเรียนทับปัดในระดับที่สูงขึ้นเฉยๆไม่ได้มันต้องพอยต์มันต้องแน่นกว่านั้นอะไรประมาณนี้ so this translate library อาจารย์บอยเสริมอะไรไหม
ก็ไม่มีอะไรเพียงแต่ว่ามันจะมีประเด็นเรื่องที่เหมือนกันกับที่อาจารย์หนุ่ยนะฮะสรุปนะครับแต่ว่าที่อาจารย์เขานำเสนอเนี่ยจะเป็นประเด็นที่ว่าทำไม renewable ถึงไม่เป็น renewable energy ในมุมมองของเขาคือเรื่องของความ reliability นะครับแล้วก็เรื่องของ security แล้วก็เรื่องของหลายๆประเด็นที่เราเอาอะไรกับมันไม่ได้เพราะว่าอย่างลมอย่างแดดเราสั่งไม่ได้หรือคือเราอยู่จะไป renew เนี่ยเราสั่งให้แดดออกฝนตกเอาเมฆออกไปเนี่ยเราทำไม่ได้ก็คือเขาใช้คำเวิร์ดอ่ะเขาใช้เล่นกับภาษาเฉยๆหรอกจริงๆก็ส่วนตัวคือมันก็แล้วแต่ใครจะมองเนาะมันก็เป็นคำหนึ่งที่ตั้งเอาไว้นั่นแหละไม่รู้จะไปทำอะไรทำไมกับมันเพราะว่ามันก็เป็นคำของมันอะนะครับคือจะเรียกว่า renewable หรือ renewable ก็ไม่เป็นไรก็เราก็รู้ว่าพลังงานกลุ่มนี้มันคือพวกนี้นะครับแต่ว่าอาจารย์เขาก็ยกขึ้นมาเป็นประเด็นในการคือเนาะเวลาเราเรียนสูงขึ้นมันก็ต้องมีไอเดียมุมมองของแต่ละคนซึ่งสามารถเหมือนอาจารย์หนุ่ยว่ามันต้องถกในอิชชูที่เราคิดได้แล้วก็อาจจะมีคนเห็นด้วยกับเราหรือไม่เห็นด้วยกับเราก็อีกประเด็นหนึ่งนะครับนี่ก็เป็นแง่มุมหนึ่งเรียกว่าแง่มุมหนึ่งแล้วกันนะครับก็
Okay now back to English any questions or discussion about the slide Pauline Rainer any all right
Thank you for your presentation. Would you talk more about the 3D printing and the air space slide? Would you go back to that? And
ที่อาจารย์เขาให้พูดถึง 3D printing ให้ฟังเพิ่มเติมอีกหน่อย
Yes, in this one, right? So what happens is material is made up of air, a carbon derived from air. It can be extracted and we can build it any unit in the air. Now, your question may be, how will it stay afloat, right? Just like drones. How does the drones remain floating? So if you make a drone in the air and float it, if you make it big size, it could be habitable by a human being. And the fans and sizes will be bigger. It will be a bigger drone, which is called manned drone. A helicopter is a drone, and there are people in it. I have invested in another company which is based out of Massachusetts called Terrafugia. And what they are doing is building a car that becomes a plane. So it flies and it lands vertically like this. It is going into production next year. So technology is moving so fast beyond our imagination. However, the ideas of this flying car is not new. The same Bond film that I'm talking about, The Man with the Golden Gun, Dr. Scaramanga had a car that flew, if you remember the movie. So that idea is not new. But the actual production at a commercial scale is going next year. So it can be built in the air because it is injectors that can inject carbon material. How does the drone stay afloat? So you just install the parts in it.
Okay.
First you build the body, then install the part, and just like any other thing. There are bio-experiments in space, right? If you see the advancement that NASA is doing, they are building a lot of things into space. A space module. What is a space module? Where people stay for 6 months. It is built there. It is not built on the ground. After going there, they built the space module. And it was floated. Because since it was in middle of the two gravitational forces, it balances itself. It doesn't come here, it doesn't come there. It stays in between and it floats. It remains in the orbit like this. Right. So that prototype machine whose photograph I can show you, this machine, we are working on now, next research is to micro-miniaturize it. Okay, make it so compact in design that it can be put on one of the modules and build it there. Problem for us, that there'll be no carbon dioxide there. There'll be no C element there. Because carbon dioxide is here because we exhale it, tree absorb it, but when we deforest, the balance changes. Now we have a surplus carbon dioxide. That's why we talking about carbon footprint. The solution to carbon footprint is if carbon can be a raw material in building. That is what we are doing. So it's a totally different approach than what is architecture is talking about. But its approach comes from the brilliant science, engineering, and technology. It's not from architecture. Any other question?
May I translate? นิดหนึ่งครับเมื่อกี้ผมแปล
Come
เป็น
on, students, let me tell you one thing.
It's too
You
complex
need
for
to
them.
practice English. You need to be inquisitive. You need to ask questions. Let us say somehow you got admitted. Again, when you look, you will need recommendation from professors for a job. But all 2 years of your study, you didn't speak one single word, you never asked a question, you never interacted with professors. How can professors